In this video, we're going to go into how to prove that a figure is a parallelogram. So in the last video, and if you haven't watched it yet, you should go do that. We go over the properties of a parallelogram and kind of how to apply them in numerical examples. But in this case, we're going to go over the criteria to prove parallelograms and kind of using markings of different diagrams to help us determine whether or not a shape is a parallelogram. So you want to make sure you're lifting up the first three flaps. We're still writing in the parallelograms tab of this. So you should have the title, quadrilateral, and the trapezoids tabs all lifted up as you take notes. So we already have these properties and we should already have pictures drawn down. This should already be done. If this is not done in your flipbook, you need to go back to the other video to make sure you have everything included because we don't have any pictures for this portion in this video. So again, we have a specific type of quadrilateral, right? And we know that it inherits all the properties of a quadrilateral, and then there are some new properties that really help us classify this as a parallelogram. Now, there are 5 different ways to prove that a figure is a parallelogram. You guys need to write all 5 of these down, and you're expected to know and remember all 5 ways to prove it. Now, eventually, as we practice a little bit more, you guys are going to be able to choose which route you want to go, but you are responsible for understanding all 5 of these routes. So the first thing that you can do is show that both pairs of opposite sides are parallel. If you have a figure and you can show that, bam, you have a parallelogram. That's it. You don't even need to show anything else. So either of these routes, you're doing that and that's it. So for example, number 2, option 2 is you can just show that both pairs of opposite sides are congruent. And if you do that, then bam, you have a parallelogram. Number 3 says, and this one's a little bit tricky, so you want to make sure you're really taking a second to digest what this actually means. So it says, show that one pair of opposite sides is both parallel and congruent. So let's go back and draw some pictures. And you guys should be doing this too. You could draw them small, and it doesn't have to look perfect. So for number 1, to show that both pairs of opposite sides are parallel, right, are markings, because if we're doing a proof, right, you're marking your diagram as you make your statements. So if your diagram ends up looking something like this, where you have both pairs of parallel sides labeled, then yay, you have a parallelogram. Number 2 would be if you have your figure like this, and then you eventually get to both pairs of sides, opposite sides being congruent, right? So this is one pair of opposite sides being congruent. This would be another pair of opposite sides being congruent. Bam, you would have a parallelogram. Now this one says, show that one pair of opposite sides is both parallel and congruent. So it can be either or, and I'm going to draw both examples because there are 2 pairs of sides, right? So let's say you're dealing with the top and bottom pair of sides. So you can show that that pair is parallel and congruent, right? Or you can go the other route. Let's go for the left and the right one. You can show that the left side and the right side are both parallel and congruent. And if you do that, then bam, you have a parallelogram, right? You don't need to do both. It just says show that one pair is parallel and congruent. Number 4 says show that the diagonals bisect each other. So you would have your diagonals here, and you would eventually somehow get to the fact that those 2 pieces are congruent to one another, and then separately these 2 pieces of the diagonal are congruent to one another. And then number 5 says show that opposite angles are congruent. So if your diagram looks, and it has to be both pairs, right? It can't just be that one pair. It has to be both pairs of opposite angles. If you get something like this, then you're good. Then you have a parallelogram. Now be mindful, these are all markings, right? Like for example, you might have numbers in some cases. So instead of having your singular arc, maybe you have like 20 degrees and 20 degrees, right? And then maybe you have 160 and 160. So when you have actual numerical values, it's the same concept. So again, you are responsible for knowing all 5 of these ways. And when we get there, you're responsible for knowing how to prove them all 5 ways as well. So we're going to go back to our family tree, which we kind of already did, so we can actually skip this part. You should have already had this done from the last video. If you don't have it done from the last video, you need to go back and do that. So we're going to look through a series of photos to see if we can prove the figures to be parallelograms, and then we'll say which theorem or which way we're using. So here I have that this pair of sides is parallel, and one of them is 6 and one of them is 5. So as you're looking at your flipbook, we can go back to the ways and see which method the picture was trying to use. So I have information about one pair of sides, so I think that picture is going for this one. It says show that one pair of opposite sides is both parallel and congruent. However, the one pair is parallel, but they're not congruent. So no, we can't prove this. Oh, my stylus is really giving me trouble here. So we can't prove because one pair is parallel, but not congruent, right? We would need to have maybe like 6 and 6 or 5 and 5, right? Okay, wonderful. Next one. So we have information about both pairs of opposite sides here. So let's see what we have. It's giving us that this pair of opposite sides, 7 and 7, we know that's those two sides are congruent, right? Then we have these two sides are 9 and 9. So if you go back, I'm not going to keep flipping back to that slide because you guys have it in front of you. But we see that both pairs of opposite sides are congruent. So yes, it's a parallelogram because both pairs of opposite sides are congruent. Now you might be thinking, why do we even care? Well, this is good because once you know that something's a parallelogram, right? We were able to conclude that it was a parallelogram just based on this criteria, but we're able to make so many other conclusions. For example, if I wanted to mark this diagram up, you guys don't have to do it, but just to show you, for example, just from this info, I know it's a parallelogram, right? So then I know, okay, I know opposite sides are opposite angles are congruent, right? I know that both pairs of opposite sides are parallel. I also know that if I had diagonals here that they would be bisecting each other, right? So it just goes to show you that once you have that a figure is any figure, right? Not just parallelograms, but once you can conclude that using one of the ways, you can make so many other conclusions, and that's kind of the goal of this. Now let's see here. So we have 85, 85, 95, and we want to know if it's a parallelogram. So one of the ways, and this is just striking my brain because I've been doing this forever, but this is trying to use the theorem or the method that opposite angles are congruent, that opposite angles are congruent. So we have to test that though, because I know for a fact, without even doing anything, I know this must be a quadrilateral. Quadrilateral was the most basic shape. It's got four sides, and we know that those angles are adding to 360, right? So let's find what that missing angle is. So 95 plus 85 plus 85 plus, I'll just call it x, is going to equal 360. So if we do 85 plus 85, that's going to be 95 plus 170. Bear with me, I'm doing mental math. 170 plus 265 plus x equals 360. And then we would get 95 degrees. Perfect. Okay, look at that. 95 degrees. Bam. So yes, it is a parallelogram because opposite angles are congruent. Wonderful. And again, if we wanted to make all the conclusions and make our picture just as ugly as this one in the middle, we could. All right, next. Here we have, I already know this one's talking about diagonals. Dead giveaway. And we know that diagonals are supposed to split each other, bisect each other. They're supposed to split each other. This one too. They're supposed to split each other into two congruent parts. Diagonals. Okay. So here we have 4.3 and 4.3, and these two pieces are congruent. So yes, it is a parallelogram because diagonals bisect each other. All right, next, we have the same situation. I'm lying, we don't. Okay, so here we have that these two pieces are congruent, but then this is 7.1 and this is 7.2. So these two pieces are not split evenly. That's a problem. So no, this is not a parallelogram because diagonals are not bisecting each other. Big problem. Even though we have that these two pieces are congruent, we need to have the other diagonal being split evenly as well. Alright, in this diagram, it looks like it's giving us info about one pair of sides, and I know that condition, just because I study this so much, is that one pair of sides should be both parallel and congruent. So we have the parallel aspect down, however, 11 is clearly not congruent to 10, right? No, because the one pair of sides is parallel, but not congruent. Now again, if this was maybe 11 and 11, then we'd be good. Or if it was 10 and 10, then we'd be good. But it is unfortunately not. All right, last three. Ooh, this is interesting. Okay. So this one, all four of our sides are congruent. So to me, the theorem that it's gonna try to use is that both pairs of opposite sides are congruent. That's still true, right? This is one pair of opposite sides. That pair of opposite sides is congruent, right? And then in blue over here, we have another pair of opposite sides, and those opposite sides are also congruent. It doesn't really matter that they're all congruent to each other because we're still satisfying that criteria of both pairs of opposite sides being congruent. So yes, it is a parallelogram because both pairs of opposite sides are congruent. Wonderful. Okay. In this diagram here, it's giving us info about the angles. And I already know it's showing me my opposite angles. All four of the angles are congruent, right? But more importantly, I see that these opposite angles are congruent to one another. So that's our reasoning why it's a parallelogram. Yes, because opposite angles are congruent. And I would even be more specific and say both pairs. Okay, last but not least, we have two 90-degree angles given to us. And it wants to know if we can prove that this is a parallelogram. Well, we can't really do much here. Like, we have a 90-degree angle here and a 90-degree angle there, so that's good. But we don't know enough info about this angle or this angle, right? We can't say that any of those two are 90 degrees because there's nothing there that will tell us that. But if we did have that this was 90 degrees, then yeah, we can say that that last one is 92, but we don't have that. So no, there's not enough info to say, because I think the goal would be to say that opposite angles are congruent. So not enough info to say that both pairs of opposite angles are congruent. All right, so make sure you guys have all of that stuff down. And also, if you guys need to pause or go back for anything, you can also do that.